Start. So what are special numbers? So in mathematics, special numbers are actually called perfect numbers. So let's understand what are perfect numbers. Perfect numbers are nothing but a number whose sum of all factors is a number itself. What I mean is, let's say you have a number 6, and remember 6 is the smallest perfect number in mathematics. So why is it a perfect number? Because sum of all the factors of 6 gives us 6. And before that, what are factors? So factors are basically a number which can divide another number and give us remainder 0. Okay. So 1 is the common factor for all the numbers existing, because 1 can divide anything and give us remainder 0. So the factors of 6 are 1, 2 and 3. You can also check like this. 6 divided by 1, you get remainder 0. That means 6 modulus 1. Remember, we are going to use this in program. So remember these concepts. 6 modulus 1. That means divide 6 by 1, and what is the remainder? Remainder is 0. Now 2, divide 6 by 2 and take the remainder. That means 6 modulus 2, 0. Now again divide 6 by 3 and take the remainder. So that means 6 modulus 3 gives us 0. So why not exceed 6? Because numbers after 6 will never be the factor of 6. In fact, uh, let's say 6, half of 6 is 3. So any number after 3 will never be a factor of 6. And this situation applies for all the numbers. Okay, be it any number. For any number, any factor, okay, factors can never be more than the half of the number. Okay, factors can never be more than half of the number. So for example, for 6, the factors are up to 3, and what is the half of 6? The half of 6 is 3. So this applies for all the numbers. That means you have to go to the half. You have to target the half, because numbers more than half can never be a factor of the given number. Okay. So now, as you can see, so there are 3 factors of 6, 1, 2 and 3. Add them all. 1 plus 2 plus 3. What gives? 6. So that means adding all the factors gives us the number itself. And there are 2-digit number, 3-digit number, even 4-digit number like this. For example, smallest is 6. The next perfect number is 28. Okay, you can take it out. You can take all the factors of 28. Factors are the numbers which gives us remainder as 0. And for 28, just check it out. And as far as I think, it will be the highest factor will be 14. Okay. So as you can see, again 14 is the limit. You don't have to go beyond 14, because you can divide 28 by 2. That gives us the half of 28. So any number after exceeding half of 28 will never be a factor. So 28 is another example. There is 496, which is a 3-digit number. It is also an example of perfect number. And then comes 8128. This is also a special number, or you can say perfect number, because all the sum of its factors gives us 8128. Okay, so these are some of the examples. So now let's check it out in Microsoft Paint. So now we will build the logic, or you can say we are going to build the algorithm. An algorithm is the series of steps that we are going to follow while writing the program. So let's begin. Let's take 6 as the smallest number. Okay. Yeah. Now all you have to do is, what are the factors of 6? So you have to run a loop, or you have to go from 1, because 0 can never be a factor. Divide anything by 0, you will get 0. Okay, so 0 is never a factor of anything. Now start from 1. Okay, let me take the brush. start from 1. So now you are starting from 1. Divide 1. Okay, divide 6 by 1. So 6 by 1. Remainder is 0. Okay. So 1 is a factor. Okay. What is the next number? 2. Okay. Now divide 6 by 2. 6 by 2. 2, 3 is 6. Remainder is again 0, right? Remainder is 0. Now, what's the next number? 3. Now divide 6 by 3. 6 divided by 3. 3, 2. Okay. And what is the remainder? Remainder is 0. So that means 1 is a factor, 2 is a factor, 3 is a factor. Now, this is the condition. You will not exceed the half of the given number. So what is the half of the given number? So in order to find the half of the given number is 6 by 2, that means 3. So in our case 3 has already been reached. So that means we won't exceed. We will add these numbers, okay? For every time we will keep adding these numbers. 1 is a factor, okay, keep it. Again, 2 is a factor, add it. 3 is a factor, add it. Now what is the total number? Total is 6. So that means 6 is a special number, right? Okay. So now let's make the program. I hope this is clear, and if it's not, please tell me. I'll show you some more examples. Okay. Now let's run the Python shell. Okay. Okay. I'm not gonna work in PowerShell because I hate PowerShell. So now let's run the Python interpreter by typing Py or Python, whatever you like. Now let's give it a number, and the number is 28. And let's start by actually giving a perfect number. And we need another variable where we have to add all the factors. So this is the temporary variable where we will add all the factors of the given number, and if this thing is equal to the number above, that means this thing, okay, that means this is a perfect number, and this will be the case because 28 is a perfect number. So now we will use loop to iterate from 1 to the half of the given number. Why half? Because any number more than half will never be a factor. And I keep saying this because you understand what's a perfect number and what's about factors. Okay. So now I will use for loop. You can definitely use while loop as per your choice, but I prefer for loop for this action. Because whenever it's a number or you have to iterate through all the numbers using for loop, actually saves you a few lines of code. Otherwise you have to increase the value of x every single time. So that's why I'm using for in this case. For x in range, iterate from 1 because 0 can never be a factor of any number, and iterate till the half of number and add 1. Why this one? Because in Python, all the loops starting from a given number to the end, all the loops will execute one less than the end. This is the end, right? This is the end, and this is the start. There is no step. The step is by default 1. Okay. So this is the start, and this is the end. And what is the end? The number divided by 2. That means half of the number. So half of 28 is 14. But this loop will actually execute till 13 if we do not give this 1. And that's why we add 1 after it. Damn. Okay. Now we will check if the current value of x That means the current value of every iteration can actually divide the given number and the remainder is 0. If it is, that means the number is a factor, right? Any number which can divide the given number, giving remainder 0, it is a factor of the given number. So we will check if, guess what, number modulus x equal 0. That means if the present value of x divides the number and gives us remainder 0. And why remainder? Because modulus gives us remainder after divide. So if the present value of x divides the number and gives us remainder as 0, that means this is a factor. And what should we do if it is a factor? We have to add the factor. We have to add the factor. That means sum equals to sum plus x. But we can replace it, right? This sum plus equals to x. That means we add x to sum every single time it is a factor. And how can we understand it is a factor? Only if this condition is true. That means only if the current value of x divides number and gives remainder 0. And to print it even nicer, let's say print again f string. I've shown you how to work with f strings. So we write x is a factor of number. We add a new line here, adding it to the previous value of sum. Okay, just remove this line. We know we'll add it, so just current value of sum is sum. Perfect. Else, okay, do not give this else condition, okay, because it is not required. And I guess that's the end. Number next, okay, that's all I think. Stored object, why stored object? Damn. Oh, okay, now I understand. Number divided by 2 gives us 14. Okay, now if we add 1, it becomes 15. Okay, but what's the problem here? Okay, line 1, stored object. I guess there's some kind of problem having here. Let's try it out again. Let's type error, okay. Let's make it easier and let's see what's happening. Sure. If number mod x equals to 0, sum plus equals x and the same number right there. Okay. Oh, let's see what's happening. Okay. So as you can see, this was causing trouble right here. Okay. This was creating some sort of problem. It was giving us type error. So that's why I use int function to convert the whole thing, okay, the end thing, whatever will be the next value, into integer, right? So now, as you can see, 1 is a factor of 28. The current value of sum is 1. Okay, so it adds it, right? 2 is a factor of 28. Current value of sum is 3. Why 3? 2 plus 1 is 3. 4 is a factor of 28. The current value is 7. 7 is a factor of 28. The current value is 40. As you can see, it is adding up. 2 plus 1, 3 plus 4, okay, 7 plus 7, okay, 14. And now finally, 14 is a factor of 28. The current value of sum is 28. Now, if we check like this, if sum equal to number, that means this is if the value of the sum is equal to the number, and put this in brackets because this look nice. Print number is a perfect number. Else number is not a perfect number. Okay. So as you can see, 28 is a perfect number. Now let's run it in the let's understand what's going on behind things. We will understand this logic. Okay. We will understand this logic first. So now let's write the logic here. Okay. Number equals 28. Perfect. And sum equals 0. Done. Now what is the logic here? The logic here is for x in range 1, comma, number divided by 2 plus 1 int. Just make this a little bigger. Okay. Column something wrong is no. Okay, wait here. Okay, if x, okay, number modulus x equal 0, okay. Now let's begin. So the first value of x is 1. Now because it starts from 1, the first value of x is 1. So if number mod x, that means what is the value of x? 1. So if 28 divided by 1 gives us remainder 0, which is the case, that means 1 will be added to the sum because 1 is a factor of 28. Okay, what is the next number? It is 2, right? Because after 1 comes 2. Now number divided by 2. So number divided by 2, yes, it will give us it will give us remainder as 0. So that means 2 is also a factor. 2 is also a factor. Now the current value of sum is actually 1 plus 2, 3, right? 1 plus 2, the current value of sum is 3. Now what is the next number? 3. Because 1, 2, now 3, right? Number modulus 3 equal 0. But this time the condition is false. This time the condition is false. Why is it false? Because if you divide number which is 28 and divide by 3, it will never give you 0. It will give you something else but not 0. And if it is not giving 0, that means the current value of x, that means 3, is not a factor of the number, right? So 3 is not a factor. Okay. Now it goes to 4. Is 4 a factor? Yes, 4 is a factor. Why 4 is a factor? Because number mod 4 gives us 0. If you divide 28 by 4, so it will give you remainder 0, right? So now you will add 4. So 1 plus 2 is 3 plus 4, 7. So the current value of sum is 7, right? This is the current value of sum. Now 5. I mean the next value of x is 5. So if you divide number by 5, you will never get remainder as 0. Okay, so that's why 5 will not be included. Now you go 7. Okay, sorry, 6. So is 6 a factor? No, it is not. It is not, right? So because if you divide 28 by 6, you will never get again remainder as 0. So 6 is not a factor. Now you go to 7. So 7 4s are 28. Alright? So that means you get remainder as 0. Because if you divide 28 by 7, you will get remainder as 0. Then that means you add 7 to the sum. So the current value of 7 is 7 plus 7 is 14. Okay. Now the next value is 8. Now dividing 28 by 8 will never give you 0, 9 will never give you 0, 10 will not, 11, 12, 13, it will not. But when when it comes to 14, okay, it comes to 14 and the condition still matches, right? Because the end will be 15, right? This is the end. And what is the end? Number divided by 2, that means 14 plus 1. That means this loop will end in 15. But now the current number is 14, right? So 14 still continues. Now what happens is number divided by 14, that means 28 divided by 14 will give us remainder 0 because 14 twos are, right? 14 twos are 28. So that will give us remainder 0. That means I add 14 to the list. Okay, I add it. So now the current value of 14 is 14 plus 14 give us 28. Okay, but now when it comes again, okay, so 14 has been exceeded and the end was 15, right? So this will no more execute. Okay, this will no more execute. The task of this loop has been ended. But what is the final value of sum? The final value of sum is 28. Now it will check if sum equal to number. That means if this thing equals this thing, then it is a perfect number, right? Then it is a perfect number. So this is also 28. Sum is 28. The number also is 28. So it is a perfect number. If it was not, then it will never be a perfect number. Okay. So that's how perfect number works. So now let's move on to the next topic, which is Armstrong number. So Armstrong numbers are very interesting. Okay, so what are Armstrong numbers? Let's start. What are Armstrong numbers? Armstrong numbers are numbers whose total number of digits, when raised to each of the digits and then added together, gives us the number itself. Okay, so let me give you some of the examples. Okay, I do not remember the examples. Okay, just let me search it. Oh, let's search it up. Okay. So I'm going to give you examples. So 153 is an example. Okay. 153 is an example. Now let's open the paint and let me show you what I mean. Select everything. Let's delete all the mess. Okay, let's delete everything. Okay, okay, we are good to go. Okay, that will do. Done. Now let's understand Armstrong numbers. Okay, so let's take the example 153. Okay, so number is 153, right? So if the number is 153, so if the number is 153, what you will have to do? First count the number of digits. So what are the number of digits here? Let me take the brush. Okay. So how many digits are there? 1, 2 and 3. Okay. Sorry. 3. So there are 3 number of digits, right? Now take each number from reverse or whatever you like. Okay, just take the numbers. 3. What is the next number? 5. And what is the next number? 1. Now what is the, how many digits are there? 3. Now give 3 as exponents or powers of each number. 3, 3, 3. So 3 to the power 3 plus 5 to the power 3 plus 1 to the power 3 gives us 153. Okay. So this is how it works. Okay. Take every digit of a given number, count the number of digits, how many digits are there. Okay. And finally, you know, put the number of digits as exponent on each digit, add them together, and it will give you the original number. And if this is the case, then that means it is an Armstrong number, else it is not an Armstrong number. Okay. Now some of the other examples include, there are, these can continue to 4 digits, 5 digits, even 6 digits. Okay. So let's see if I find another example. Okay. Let me open the Quora app. There's a hell lot of examples here. Yeah. So another example is 371. So let's say 371. Okay. Now let's take a 4-digit number. Okay. Let's take a 40. Now you may think, is 1-digit number an Armstrong number? If you're thinking like this, then you're absolutely right. Because the reason behind this is, if I take 1, so 1 has only 1 digit. So 1 to the power 1 gives us 1. So that means 1 is a palindrome, sorry, 1 is an Armstrong number. If I take 8, so 8 to the power 1, because 8 only has 1 digit, so 8 to the power 1 will give us 8. Similarly, if I do 5 or 9, whatever, 5 has only 1 digit, so 5 to the power 1 will give us 5. So that means all single digit numbers are actually Armstrong numbers. Okay. Now coming back to my point, there are 4 digits, 5 digits number which are actually Armstrong numbers. So for example, let's take 1634. Okay. 16334. This number is an Armstrong number. Why is it so? Okay, now count the number of digits. The number of digits are 4. 4, okay. Now take each digit, take every digit. 4. What's the next digit? 3. What's the next digit? 6. And what's the final digit? 1. Okay. So how many digits are there? 4. Now give 4 as the exponent or powers of every digit. 4. 6 to the power 4 and 4. Now add all of them. add all of them, and this will give you the same number. That means it will give you 1, 6, 3, 4. Okay, there are 5-digit numbers, and the example is, let me give you the example. The example is, yeah, it is 54748. Okay, so this is also an Armstrong number, and why is it so? It has got 5 digits. So the first step is to take 5 as the power of all the digits. So again you do 8 to the power 5 plus 4 to the power 5 plus 7 to the power 5 plus 4 to the power 5 plus 5 to the power 5. It will give you this number. Okay, so it will be an Armstrong number as well. So what is the logic? What will we do? The first step is to count the number of digits in the number, and the next step is to take out each number, and then yeah, all you have to do is give the number of digits as the power of the number and add it to the variable. And what I mean is, let's start a Python interpreter. I will show you. So let's start a new shell. Okay, exit. I would have never done this if I were on Linux right now. Cls Py. So now if I start number equals to, let's take an example. What is the example? Yeah, let's take 153. And again, there is a temporary variable where we will store everything. So now if we run loop, now which loop will you run? Remember last time what we used to count the number of digits? Exactly, we will use while. While, you guessed it right, number not equals to 0. Okay, not number equals to 0. Let's copy this number in a temporary variable. So I copied this number into another variable so that we do not lose the original number. Now we perform all the operations on this variable, or you can perform operations on this variable, but this would be better. Now if you use while temp not equals to 0, okay, all you have to do is, okay, let's take another variable. Okay, let's start from the beginning. So number is 153. Sum, where you will actually add up all the numbers, is 0. Temp, where you will copy the original data, that is the number. And finally count, or you can say digit count equals to 0. You will require these variables, right? While temp not equals to 0, tab, and you will add a number, right? Digit count plus equals 1, and then temp divide numbers. Okay. Temp divide by 10, because you remember dividing by 10, if you divide, float divide. Actually, if you float divide the given number by 10, it will actually lose one digit. So now if I press hit enter, so what is the digit count? So it is 3. So value of digit count is 3, right? Because it has 3 digits. Now what we will do is, we will use a for loop for x in range 1 the number plus 1, 1 because no, no. Okay, we will use while loop again. Okay, do we need some other variables? Yes, I guess not. Okay, if it requires, I'll do it again. While number, now we will perform operation on number. While number not equals to 0, what we will do is we will take each number out. Okay, sum plus equals to number mod 10 star star digit count, right? And what will this do? Sum plus equals to, that means sum equals to sum plus number mod 10, that means take out the last digit, and then star star digit count, that means whatever is the digit count, whatever the value of digit count is, that means the total number of digits, give it as a power, that means as an exponent. Now what we will do is, okay, number mod, okay, because you will actually remove one digit, right? So what is the value of sum? Let's check it out. Sum, as you can see, the value of sum is 153. So now if you do, if sum equal number, print number, oops, sorry. Okay, this won't work, okay, because I have already made the number 0. You have to take another copy, okay, you have to take another copy. Just like here you have copied number into temp, you will have to copy this number into another variable, because you have already made the number 0. Now the number is 0. So this won't work actually, okay. But this is what you will have to do. If sum equal to the equal to number, that means it is an Armstrong number. So basically make two copies of this number. Make two copies of this number. As you can see, the sum's value is 153. That means 153 is a Armstrong number, is an Armstrong number. So now let's do this again. So okay, for next example, let's take the number. Let's take the 5-digit number 54748. That is 54,748. Okay, let's take this number, and we need some other variables. Let's say sum, and we need num num1, or let's say num copy 1, num copy num copy 1 equals to, we copy the number here again, num copy 2, we copy the number here again, we need a digit count, and that's all we need. Okay, so now I go while num copy 1 not equals to 0, and while it is not 0, let's do this. This loop will count the digits. Okay, so how to count the digits? We will just digit count plus equals to 1, and we will do what we will do is num copy 1 double divide, that means float divide equals to 10, and perfect, here we go. And this is what we are going to do to count the digits, because every iteration, if you float divide the number by 10, it will actually just remove one digit until it becomes 0, and after that it will not execute. Okay, so you get the total number of digits right here. So now that we have the digits here, we have a digit, that is we can say print digit count, and here is a digit 5. Now we will actually calculate the sum, okay, while num copy 2, because the one has been, the job of number of the num copy 1 has ended, so now we will take num copy 2 not equals to 0. Okay, not digit count. Okay, what we will do is sum plus equals to, that means sum equals to sum plus whatever. Okay, this is the same as sums plus equals to. We write num copy 2, we write num copy 2 mod n. This will give us the last digit of the current number. Okay, by exponent digit count. So basically this means that whatever the digit count is will be the exponent. Okay, will be the power of the number, will be the power of the last digit. Okay, because doing this will give you the last digit of the number, right? Sum plus equals to num copy 2 mod 10. So that means last digit with the power of digit count, that is a total number of digits in the original number. Now what we will do is num copy 2 so divide 10. So this will actually remove one number every single time, right? Now if sum equal to number, print number is an Armstrong number. Armstrong number. Else is not an Armstrong number, right? So as you can see, 54748 is an Armstrong number because the value of sum, print sum, is equal to the number. Okay, the value of sum is same as the original number. So that means this is an Armstrong number. So here we have covered all the three concepts using loops, using while loops and for loops. Okay, so I hope now it is a bit more clear. And when we move on to the basic data structure section, you can more you can clearly understand it more. Okay, because in the basic data structure section we will use nested for loops, nested while loops, and all those stuffs a lot more than you can use here. Okay, there are lots and lots of applications.